Rightio, so thanks to Keith of Cadwax. It's called Rhino Ring now, I think, that little fella up there. I took my idea to him because he's a pretty good coder. He's very open to new ideas and a nice guy to boot. Alright, so I explained what my needs were. I sent him a bit of a video and also my DeskProto project files and the needs, the requirements of this project. Right, so to show you first of all what it does and then the usage of it, let me just shoot a bit of a clip. So we have a ring over here. I want to, before I start anything else, I want to make sure that people that are downloading the script from Keith understand that this is not a one-button solution. If you don't know how to mill and you do not know how to work with DeskProto, this is not going to help you. This is not going to do anything for you except probably break a lot of cutters and maybe ruin your equipment if you don't know what you're doing. Alright, the DeskProto project files that I've written to handle about 90% of the type of work that I do. This may not represent the kind of work that you do. You might do a lot of biker jewelry and your rings are going to be bigger than the envelopes I've created. Your output, I've created my output is a Mac 2.3 in millimeters, and you might need a different post processor. So I give these project files freely, no problems at all, but I would urge you strongly to open them, check your settings inside them, and make sure that you're not going to break cutters or do anything silly or stupid when you run them. That being said, let's get going on it. So in my milling scenario, I don't have an automatic mill that picks up to A and finds it, so I use a little indexing pyramid over there which I line up my cutter for to A and Z when I do my cutting. Alright, so I keep the little indexing pyramid in there, and what I found with DeskProto, to try and simplify things, if you write a script, maybe Keith can do this, I'm not sure, if you go export now to DeskProto, it doesn't take the curves with. You have to then go manually, you have to grab the curves, export them as DXF curves, and then you have to go into DeskProto and you have to import the DXF curves, and it just becomes a long-winded way of doing things. So what I've done is the curve that represents my ground plane is inside there, and I just pipe it with some arbitrary amount, I don't know, 0.1 mil, whatever it is, so that it's a piece of geometry. Okay, and what I've done is I've asked Keith to script this so that it will mesh this, including that curve and the little supports and the little indexing pyramid. It'll mesh it all out, dump a STL into a folder, and start DeskProto with all the geometry in place by loading a predetermined project file that I created for DeskProto. That project file will set up a 10 degree 0.127 millimeter cutter. It will also set up a 3.17 millimeter cutter. The 3.17 will do a roughing pass with 0.3 skin, and then the 10 degree 5 thou cutter, the 0.127 millimeter, will come in and run a finishing pass across the whole lot. It does not cut your keyhole. I've left this blank on purpose because you will need to inject whatever code it is you need for your keyhole. Some mills have got 3 holes, some have got a square hole like mine, some have got 2 holes up the middle. The Proto Wizard one's got a triangular hole in it. I cannot cater for everyone's milling machines. Okay, so that being said, let's have a look at how this works. So you've set up your internal supports for the rotary pass, you've set up your external supports to hold the model into the wax, and you've taken what would be ostensibly your ground plane, the ground plane curve or your milling window that you don't want to exceed, and you've piped that. Alright, so let's go to Keith's job now. We go to Rhino Ring, we go to milling, and we go to DeskProto. At the moment we're busy beta testing this, and I've only created the two the two templates, one to do a flip cut, a cut at 0 degrees and a cut at 180 degrees, and the other one to do a rotary on that same part. Okay, so obviously you would start out with your flip, so I just want to define what the parameters of a flip is. Those of you with milling machines would know that I'm looking at the top down, and this piece is orientated, the rotary is over here, and your wax block is facing away from the rotary like that. I call that a flip cut. Refer to your own documentation for whatever it is you call it. So with that geometry oriented, alright, I'm going to go into Rhino Ring, and I'm going to go to milling, and I'm going to go to DeskProto, and I'm going to go to flip. Command line says select the objects, so I grab all of this and I press enter. Okay, and previously what you would have been doing in this case is you would have been grabbing that, you would have been export a STL, you would have copied the STL to a folder, then you would have opened DeskProto, then you would have imported DeskProto, then you would have set up your operation and your part parameters, and then you would have been generating some mesh, so generating some path. Okay, so basically what this script and the project files have done is they've automated all of that, so that once you click that button, it will open my template file with all the parts already there and the geometry injected. Okay, and all you really need to do now is go to options, create, extra, and calculate all toolpaths. So what will happen now is it'll generate all these parts at one go. To explain what these parts are, okay, so all of them are written. You can go in and double check them. There's the roughing pass. Everything over there is cut. There's the flip. I've already put in under advanced, I've included all the settings to do a flip. For those of you that are wondering what my safe Z was, I've put in 90 mil. You know your milling machine. If it can't go up 90 millimeters, you need to put in whatever value is going to work for you at that point. So to reiterate, if you don't know how to use DeskProto, I don't recommend you use this until you've checked the project files that Keith will supply with this. All right? The warning from Lex. Lex is also a fantastic guy. Okay, read that warning, because you can send your cutter straight into your rotary face and break stuff really, really badly unless you know what you're doing. So this will work for all the Minitech mills because we have quite a big Z limit, but you need to also understand that if the ring that you're trying to cut is more than 90 mil big and you only pull it away to 90 mil, you've got problems. So like I said, this is not to replace learning DeskProto. If you do not learn DeskProto, or you do not know what you're doing in DeskProto, these project files can and will break your machine if used incorrectly. All right, so that out the way, let's have a look at what we've done. So we've created the roughing, we've done that. Here's the finishing. So to tell you what tools I've used in here, in this operation I've used a 3.17 mil or 1H flat end mill with a 0.3 step over and 0.3 skin thickness. So that'll, you'll use your 3.17 millimeter end mill. It'll go in, it'll chunk away all the bulk of the wax. It'll flip it over and we'll do the same on the other side. Okay, and so this operation you would export as one thing. All right, there's a bug or a glitch in DeskProto right now that doesn't allow this to happen automatically. You can get us to include the automation of this, but what will happen is instead of exporting these two as one path, it will export them as two separate paths, requiring you then to concatenate them in Notepad. Lex has assured me that in the next version he will see about addressing this. At that point you wouldn't even see the screen. The path would just simply appear on your desktop. So from this point onwards, what you would need to do is simply output your paths. So we're going to click write the paths, and we're going to put on the desktop wherever your project is, and we're going to go flip rough like so. It's warning you that this is part 1 of 2. Yes, we know about that, and just go yes, and it's going to write that path. I'm going to open with Notepad and show you. Open, select a program, Notepad. Okay, so your path is in there, and like I said, if these numbers don't look good to you, it's probably because you're using a different processor. You would need to set that up in your project file and then save the project file out. All right, and then you would use your finishing operation. So we'd write, we'd write that one too. Okay, same deal. So we're going to call it flip finish. Yes, and that path will be written. So really the only user interaction you've had was to be in Rhino and click on DeskProto flip, and then come in here and go options, create paths. Really that's 2 clicks so far. So taking what can be a long tedious job and turning it into 2 clicks, I think was quite a successful project. Alright, so now to show you the rotary segment of that, this of course you would save to wherever your project's going to be. Go save as and save it somewhere else. Don't overwrite the original project files. So to do the rotary on this ring, I'm going to simply rotate it around F4, bring it up that way. Of course you need to lock it orthogonally, alright? And we're going to go back into Rhino ring, we're going to go back to milling, and we're going to go to DeskProto, and we're going to go to rotary. What do we want to mesh? That is grouped. I'm not entirely sure why it's ungrouping it. To select it, like I said, this is still in beta, so you'll have to just bear with us a little bit. Okay, so that's your rotary, that's the objects we want to mesh, and exactly the same thing. Okay, all it's going to do is mesh it out. It's going to dump a STL into a predetermined folder, and it's going to open DeskProto in the rotary mode. Alright. Now, given that DeskProto is 64-bit and it will happily run on the other side, my recommendation would be to start with your rotary pass, click on DeskProto, DeskProto Rotary, or whatever it is. Hang on a sec, let that go. Okay, so yes, go yes. Right, that error over there was nothing to do with Keith's, it's just that the last time I opened this file I had an STL on my desktop. It automatically detected it's not there, but it did find it in the right folder, and do I want to load it, yes or no. Now, rotary parts are notorious for taking a lot longer than flip parts. So the way that I would probably see this tool being used is for you to open up the rotary section first and go write parts, because this may take a while. Alright, so what I would do is go back to your Rhino, okay, and rotate around F4. Would start with your rotary and then come back and do your flip. So at this point I go back to Rhino Ring, because you can run it again. You go and go flip and grab all this geometry, press enter, and open another instance of DeskProto. Let's see how the other one's doing so long. It's busy calculating. Now, the DeskProto project files that we're supplying, the settings are really loose. You may need to go in there and increase the fineness. I don't know, you are your own jeweler. You know what it is that you need to do to keep your customers happy. You need to cut it 20 micron step over, 30 micron, 40. I'm not going to guess that for you, because I'm not entirely sure what you need. So excuse me. So while that's generating the rotary path, you could have gone in and start doing this now. Alright, extra, and calculate all toolpaths. So in the time we're sitting talking about this, we've got one DeskProto is busy calculating the rotary, the other one's busy doing the flips, and that's all done. Job finished. Now this one will take a bit longer because the extreme fineness of the threads, of the step over that I've put in there. I think I used 20 micron or 15 micron or something like that. But in the meantime, while that's doing that, you can be in here exporting these parts, and by the time you finish doing all of this and you get back in there, you're probably ready to be done. Okay, so you've taken what can be a long, tedious job and you've turned it into 4 total clicks to generate the files that you need. Once Lex addresses the bug that stops this from outputting the NC files properly, it's going to be even less clicks. Okay, so I'm going to just cancel that for the moment and close that off, and then once again just iterate that this is in beta. If you do not know or understand what I was talking about now, I do not recommend that you use this tool. Okay, go back to whichever way it was that you know how to make your DeskProto work that doesn't kill your machine. This is an automated setup to help speed up a system that I know works very, very well for my machine. By all means, if you have a system that you know and you can send me an STL file or something of what your normal setups are, and that's not working with this, I can increase the parameters in the bounds in the DeskProto project files, increase them a little bit more to take your size of projects. If you know anything about DeskProto, you'll be able to go into the C drive, into, is it program files? I think it's Rhino Ring, Rhino Ring, no, in there, Rhino Ring, and I think that you will find the project files somewhere. Is it in there? No, where have they gone now? Anyway, we'll have to speak to him about that, but there's somewhere in there is a folder called DeskProto, and all these files are jumped into it. So the script does work, but it is in beta, so I highly recommend that you double check the paths that are generated on your machine to see if they're going to work for you. Again, to Keith, thank you very much. I'll generate a few more project files for you, a few more templates for 4-sided indexing, 8-sided indexing, that sort of stuff. and give them to you so that we can complete this project. Thank you. Cheers, Chris out.